now I already got the fine introduction, so I don't really need to do that, but I'm Jacob. As already mentioned, I've been around since 2015, where I wrote my first smart contract. I don't know if you can see it all right, but this is a small part of it from my bachelor thesis that I wrote back in 2015 on Ethereum. And after that, I was offered an internship at the EF working on the Python client. Then I spent 5 years building payment channels, something called the Radar network, which turned out we were just 10 years too early, and it's very relevant at the moment. Then I led a project called Beamer Bridge, worked on hack prevention tooling at Filex Systems, and now I recently joined as the DevRel for the Solidity language. So yeah, that's a little bit about me and why I'm standing here. And what we're going to talk about today is Solidity, which has also been around for around 11 years. Back when I wrote my first smart contract, there was no tooling whatsoever. I think we used something called LS0 to deploy contracts. I don't know if anyone's ever worked with that, but it was absolutely terrible. So I can definitely say that tooling and the language itself has come a long way, but there's still a long way to go as well, and there are a lot of things we can improve drastically. So just last week, we had a new release, 0835. I'll talk a little bit about what that included a little bit later. But in general, Solidity is maintained by the Argo collective, which is the spin-out from the Ethereum Foundation. We spun out around a year ago, and it's an independent, not-for-profit that focuses on building Solidity and a bunch of other tools like the Fey language, Sourcify, AGVM, ACT, and FDebug. Sourcify gave a talk earlier this morning, and a little bit later, I think actually right after my talk, there's a workshop with ACT that you should join. I'll tell you what the name of the room is a little bit later. I forgot it, but it is in my slides. So, what hurts in Solidity? Some of you might say everything. I don't know. I know there are a couple of critics in the room, but we did our survey, the annual Solidity survey, and finished the report like a month ago, I think. And surprise, most people out of the around 1,000 people who filled it out still think that Stack to Deep is the biggest pain point. And Stack to Deep has been an issue for a long time, indeed. Other than that, we have like debugging was mentioned by a lot of people. There's not really a good debugging tool, which is also crazy after this long. And then the byte size of contracts is also frequently mentioned as an issue. Those are the three biggest pain points that we saw. So yeah, what are we basically doing about these? I'll get into that deeper later. But first I'll say what we released last week in the 0835 release. We had our first comp time built in the language. It was a small one, but it's the first one, so that's progress, I think, and that's something that we will also be able to benefit from in the future. Then we introduced the experimental flag, which is now like a single flag that you can enable or disable. It's disabled by default, of course, for new features that are unstable that we're working on. And one of the features that we introduced is the via SSA CFG, which eventually will fix Stack to Deep. It will also make the compilation time much faster. So it's adding a lot of very nice things. My colleague Moritz has a very nice talk on this from the Solidity Summit back in DevConnect in Argentina. So if you just Google for Solidity SSA CFG, if you can remember that amazing shorthand, then you'll find a very good talk on the specifics of it. I'll also talk a little bit about what it is. As I said, number one complaint at the root, like most of you Solidity developers have probably ran into this issue before, but what it actually is that the EVM has a constraint that you can only basically address the top 16 items on the stack, and that means that once you have more items at a single point in time, you get this error. What are we doing on the compiler side to fix this? We have the SSA CFG that I just talked about. So the code gen here will basically do memory spilling if we have more than 16 items live on the stack at any point in time. So that will remove stack to deep effectively. We are targeting to add this to the SSA CFG end of Q2. But bear in mind that it is still going to be an experimental feature, and we don't have a good outlook. I don't have an outlook for when it will go into production, but it is coming. So I think that's very nice. A little bit late, but it's happening, and I think that's the most important thing to focus on. On top of this, there's also EIP 8024, which adds some new opcodes, duben, swappen, and exchange, that allow you to do around 272 stack items. So they complement each other very well, and I believe that 8024 is confirmed for Amsterdam, which should be this summer. So that is something to look forward to indeed. But there are also things that we cannot patch our way out of. We cannot patch our way out of missing language features. Solidity is, as I said, 11 years old. There were maybe some design choices made in the early days that were not fit for where Solidity and Ethereum is now. So we have to try to fix that. And I've mainly talked about like DevX stuff until now, but there's also the security side of things, right? And it's stack to deep is not what causes hacks, right? It's bugs, and that's why we are doing Core Solidity, which is more or less a redesign of the language that has a type system and some more like functional aspects as well. It's the same EVM, it's basically the same backend, but different semantics. I'll go through a quick code example, comparing how you do something in Classic with how you do it in Core. Here we have like a payment handler, and we have an enum of payment types, and we have then a struct that has a payment type, but there's no way that we can kind of verify that if you have a native payment type that it only takes address of 2 and the amount, right? You could have a native payment here with token ID, which makes no sense. And the only way to kind of check for these things is through through require statements or if statements in the function itself, which happens during runtime. And if you then, for example, want to add a new payment type, you add the type, but you're not handling it in all your functions, the compiler will basically like slowly or silently just ignore it. And you'll probably ship this code. So that's problematic of how Classic Solidity works right now, and how we could solve this in Core Solidity is basically by having a data type payment that has the different payment types that we talked about before, and then we pattern match and make sure that basically a native payment type always takes an amount for this calculate fee. So we make sure that you don't throw around different payment types, and if someone added in ERC 1155 as a payment type, all functions that don't handle this in the match would fail in the compiler, or during compile time. So basically we have a compiler that now tells us whenever we're not handling a case. And I think this alone will help general like smart contract security improve quite a lot, and it helps the developer through like handling all these cases. So this is one of the features that Core Solidity will have that make it easier, or let's say harder, to introduce bugs in your code. So we talked about making it harder to deploy bugs. One thing I lately enjoyed doing is reading about aviation, because in aviation you have like really actually very good standards around everything, and they have for 100 years or more focused on making it as hard as possible for human error to happen, right? We cannot get around the fact that humans will make mistakes, they will introduce bugs, but we have to make it as hard as possible for them to do it, and I think we can do that by introducing something like the pattern matching, where the compiler will simply refuse to compile your code when a case is missing, for example. And in this case, I think also the life of auditors might be easier, because they don't have to worry about checking like all cases covered in a case like the payment that we saw before. So yeah, I think having a language that tries to catch as many bugs as early as possible is going to be a very nice thing for a lot of developers. Another thing is that we'll have zero runtime cost with something like pattern matching. You could, if you're careful, develop a similar statement in Joule and deploy that. So basically what it does is like remove the wrapper types, and you just have no extra runtime cost for something like the switch statement that we see here. And this is basically what the pattern match before would compile into. There will also be generics. So for example, we have something like log in Forge, which has 381, I think, handwritten log functions. And in Core, you have generics, so you basically have one function per arity. So it also gives you, it basically generates all these special functions at compile time, and adds no extra runtime cost. So it's some pretty neat features you get out of this. The rest of Core, there are also other things I'm not mentioning, but we will remove inheritance. This is probably one of the bigger things that some people won't like too much. But you can do code reuse via traits and like composition mechanisms. There'll be first-class functions and closures. We'll have like type invariants almost everywhere. And as I mentioned earlier, we also have comp time evaluations. So, for example, what I said, ERC 7201 that we introduced is the first step. And all the work we currently do on the classic compiler around these things, we can carry over to Core as well. Some of the things mentioned from like people in the survey, they said like we want to see better error handling in Core Solidity, and you get that from basically from the pattern matching. All right. So what's going on underneath everything in Core Solidity? In Classic, we have API encode or like whatever precompile is written in C++. And in Core, it's part of the library, or can be library. We will have a standard library, which I personally think is going to be great. And that is written in SAIL, and SAIL stands for Solidity Algebraic Intermediate Language. And it's a pretty simple language. It has 8 constructs and 1 built-in type, which is called word. And it will allow people to read and audit and debug, basically, or replace any standard like function that they use in the standard library, which adds, I think that's quite great that it gives a lot of flexibility for what you can do and allows for people to contribute easily to the standard library. You will be able to just open a PR to the language instead of having a new compiler release to add a new precompile. I think having a standard library is going to be very powerful compared to not having it in Core Solidity, in Classic Solidity. And you can also choose to just disable the standard library, and then you're left with basically a typed UL, and you can do more or less whatever you want. And for the standard library, we are talking to different people in the community as well around coming together and defining the standard library. Like, we want to know what people want to see in the standard library. So if you have any requests on that matter, please also come talk to me after, and I'll be happy to include you in the working group, or at least bring your feedback there. And yeah, because Sail is such a small language, the goal is also to formally verify it. And we are also looking into doing that in something like Lean. So I think, just to wrap up on that, I think it's like the next natural step, kind of, and the 11 years that Solidity has been in development, the programming languages scene looked quite different 10 years ago. So it's also a chance to kind of catch up and use some of the more modern language features that are around now, and like bring or take more inspiration from a language like Rust, for example. So I think it's a natural direction to go in for a language like Solidity. And what's happening in the language itself? We have Aksik, who used to work on Solidity for a very long time. He's currently porting over, or attempting to porting over the beacon chain deposit contract to Core. We're getting a lot of good feedback out of him working on that, and finding out what's missing in the language, and actually picking up some real pains that someone externally is experiencing. Then we're at a point now where you can actually write Core Solidity contracts. You can compile them and you can run tests. I'm not sure if you could deploy the bytecode. I don't recommend it, but if you're interested to try, I think it's a good project for a hackathon over the weekend. Just released last week a blog post, actually this week, a blog post on pattern matching in Core Solidity. You should give it a read if you're interested to learn a little bit more about it. And we also, last week, merged the first version of the module system that will be in Core Solidity. And as I mentioned, the stuff that we're currently shipping, like SSA, CFG, CodeGen, in Classic Solidity will carry over directly to Core. So it's not like we're like, basically all the stuff we're doing in Classic will also benefit Core in this way. And yeah, if you're actually interested in hacking or trying out Core Solidity over the weekend, find me and I'll help you get started. It doesn't take as long as you'd think, actually. So yeah, looking at backwards compatibility, of course, that's a concern for people. And we're not throwing away everything. We're basically just trying to improve on stuff, and we will have backwards compatibility. You can still interact with already deployed smart contracts, of course. And the surface syntax of Classic will be, of Core, will be very close to Classic. The example I showed earlier is work in progress. We have not yet settled on the final syntax, and we're open to suggestions on that. So if you are trying out the language and find something weird or wanted to have something differently, please provide feedback, open an issue, because it's easier for us to make changes now than it will be once we go into production. Mentioned same backend, so we still use Joule, EVM bytecode. So it should be like the tools you're used to using should work more or less the same and carry over very well, maybe with small modifications on the side of the tool. And I think inheritance is going to be probably the biggest change, or the most real change that you'll experience. But it shouldn't be too difficult to kind of use traits and composition to cover for that instead. And we are very actively focusing on not doing a Python 2 to Python 3 split. We don't want people to go through that suffering. Yeah, so to wrap up a little bit, try it out. Tell us what breaks and what you potentially like. You can find it on the GitHub link up here. As I said, it works as a prototype. Play around with it. Don't deploy anything on mainnet with it, please. We are working on a playground that will make it easy for people to try it out in their browser. A production-ready compiler is probably not going to happen in 2026. It just takes a long time to, I don't know what Philology thinks about that, but we think it will take quite a long time to be production-ready with a new compiler. We don't want to risk too much money being deployed on chain and then potentially we find a bug. So there's better safe than sorry in our case, for sure. And any feedback in a structured way, if you want to provide it, go to the Solidity forum. And yeah, the sooner you provide your feedback, the better, because we are not yet at a stable spec, so it's easier to make the changes now. I think that is almost it. The last thing I would mention is, of course, there are a lot of moving parts and a lot of tools to build on, and already 10 years ago, formal verification was a big thing, right? People say it's the holy grail of security, so to speak, or verifying your contracts. And if you're interested in learning a little bit more about how we're doing that in Sourcify, in Argo, how we're doing that in Argo, then you should join the ACT workshop happening in, I think, 10 minutes or something like that in the Masaryk stage. So that's the workshop stage, just on the other side of the venue. So yeah, go there if you want to check that out. I think you definitely should. And I think that is all from me. I don't know if there's time for questions or not.
Yeah, we have 3 minutes for questions if anyone has them.
Thank you. Probably a tricky question, but how do you see languages adoption evolving, let's say, in 2 to 3 years from now?
The general adoption of smart contract languages?
Yeah, like Solidity versus Core Solidity versus other languages.
I don't know how I see it. I think it's important to have diversity. I always I think. I don't know if I want to call it competition, but it's always good to have different languages that also fit different people's needs and the way that different people prefer to write code. We saw that already, I think, with Viper as a nice alternative to Solidity. And now there are a bunch of different alternative languages being developed and also different compilers. So I think I think it's a good thing in general that it's happening. Adoption, I don't know how that will go. It'll maybe be a little bit more niche for some languages, and I think we are in the situation in the position in Solidity that it has been around for such a long time. There's a lot of tooling existing for it, so we have a head start on that in that area, right? But let's see. I'm a fan of more options, but of course I hope that people will continue to use Solidity. But it also means that we have to do our part to stay relevant.
Maybe if I can follow up, in reducing variables, what about like solidity versus core solidity? How do you think that will develop?
The plan is to, at some point, go into pure maintenance mode for Classic. So basically not add new features, only maintain it and update it so that we stay on par with like the EVM. But the plan is to just go into maintenance mode for that and focus fully on Core Solidity once it's ready for production, basically.
Okay, thank you.
Okay, unfortunately, we don't have any more time for questions. If you have one, you can ask it after the session. We need to invite the next speaker.
I'll be just outside.
Thank you
the
for your
door.
speech. Let's say thank you to the speaker and look.